I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this April 2026 lecture series, we are going to discuss about direct pressure measurement in measurement of pressure and blood flow in biomedical transducers and sensors. Why direct pressure measurement matters? Actually, the problem is accurate pressure monitoring is critical for patient care. It is very critical in critical care units, surgical procedures, and cardiovascular conditions. The affected persons are patients, clinicians, and industry people. Here, the impact is incorrect treatment, medical errors, patient harm, and increase the healthcare cost. C. The limitations of indirect methods and need for direct measurement. The limitations which involves less accuracy, limited continuous monitoring, it cannot access deep regions in indirect methods, and this indirect method is affected by external factors. These are all the limitations. And the clinical challenges are real-time monitoring required and high accuracy and dynamic response, minimally invasive procedures, and long-term stability needed. The technology gaps involves miniaturization of sensors, biocompatibility of materials, long-term stability and calibration. Here, the most important technology gap is wireless data transmission. C. Introduction to direct pressure measurement. The definition is invasive placement of pressure sensors directly into body or blood vessels for accurate real-time readings. When we need high accuracy, dynamic response, critical care, deep region access, we involve direct pressure measurement. Here, the display are recorded which shows pressure source output, catheter, transducer, and amplifier. See types of direct pressure measurement methods. First one is liquid column, and the second type site type, and third one is flotation type, flotation catheter type, and we have implantable transducers as well as percutaneous transducers. C. Catheter tip probe. The working principle is a sensor mounted on catheter tip. It converts pressure into electrical signal. This electrical signal is further amplified and processed for our instrument input. The key features involves miniaturized sensor, direct contact, reduced signal loss as well as fast response. The applications involves arterial blood pressure monitoring and intracranial pressure measurement and cardiac catheterization. See here, this applications which involves our approaches, our medical approaches for deep region process. If we need deep region access, we'll move on to direct pressure measurement. See the fluid filled catheter system and output. The working principle is the pressure transmitted via fluid into external transducer, which is converted into electrical signal. C, which involves catheter, external transducer, amplifier and display as well as flushing system. See the output, a body sensor. From the body, the sensor sends the signal. The signal is modeled, and finally we'll get the output. Types of pressure transducers, we have piezoresistive, piezoelectric, capacitive as well as LVDT based sensor. Clinical applications which involves blood pressure monitoring, intracranial pressure monitoring, intraocular pressure monitoring, and other applications which involves bladder pressure monitoring, uterine pressure monitoring, and GI pressure monitoring. And here I've included one student activity, group discussion. The question is, the topic is compare and contrast catheter tip probe versus fluid filled catheter system. Here the students, they'll understand when and how to use each method for clinical practice and critical thinking about clinical decision making. These are all the assessment questions I've included for this topic. See, The first question, a piezo-resistive pressure sensor uses a Wheatstone bridge configuration. If the resistance of each arm changes by del R, when pressure is applied, what is the output voltage of expression? Output voltage expression. Here the answer is V out, which is equal to del R by R multiplied with V in. Here del R is change in resistance. And biomedical industry oriented question, in an ICU setting, a patient requires continuous arterial blood pressure monitoring. Compare the advantages using a catheter tip probe versus fluid filled catheter system. Which would you recommend and why? And third question is, a patient's systolic blood pressure is measured as 120 mmHg. Convert this value into pascals. See, I've included answers for three questions: gate question, biomedical industry oriented question, and conceptual question. And this is our summary part. Here I've included summary about methods, transducers, applications, as well as advantages in direct pressure measurement. These are all some references for our topic. Thank you.